In this problem, we have a machine that is being moved at some distance d along a plank of wood, but that plank of wood is at an angle from the horizontal. We're asked to find its motion in the vertical direction and in the horizontal directions separately. We can do this by considering the combination of the distance and the angle to be a vector, and then we can break that vector down into its horizontal and vertical components. Let's start with part A, which asks for the vertical displacement. Remember, if we have a vector with an angle that is being measured counterclockwise from the positive x-axis, or the positive horizontal axis, then the vertical component of that vector, or the height in this case, is equal to the magnitude of the vector, or d in our case, the distance traveled, multiplied by the sine of the angle. So for this problem, we're told in the problem that the machine has moved a total distance of 12.5 meters. So 12.5 is our d, 12.5 meters, multiplied by the sine of theta, which is 20 degrees. If you put this into a calculator, and remember to keep your calculator in degrees mode, then we find a vertical displacement, or a height, of about 4.28 meters. Part B asks about the horizontal displacement. We use a similar formula, only now instead of sine of theta, we use the cosine of theta. So the horizontal displacement of the machine, delta x, is equal to d multiplied by the cosine of theta. So into a calculator, we plug in 12.5 meters multiplied by the cosine of 20 degrees. If we put this into a calculator, then we find a horizontal displacement of about 11.7 meters. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. And if you have a request or a question, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you have a lovely day. Bye-bye.